Okay, I'm using Unreal Engine 4, specifically its version 4.16.1, and I've created a post-process material that will perform colorblind simulation to allow you to see things the way that someone who's colorblind would see things. So you can use this in a game and turn on the colorblind simulation and see if there are any areas that would be difficult for someone with color blindness to be able to view in your game. For controlling the colorblind simulation, I've got a colorblind parameter collection, a material parameter collection that has settings. Let's take a look at that. There's 4 different colorblind modes that are supported: protanopia, deuteranopia, tritanopia, and monochromacy. Monochromacy is basically where you can't see any colors at all and your vision is just shades of gray. There's also a strength parameter that you can adjust to control how strong the simulation is. A setting of 0 disables the simulation. A setting of 1.0 is full strength, so you could simulate partial color blindness by setting it to like 0.5 or 0.7 to give you a range of strength on the simulation. So these material parameters can be adjusted either using Blueprint to change the values, or I've got C++ code that you can use to change them from the console command line, or you can just modify these parameter values directly and then run your game to enable a simulation mode. So a value of 0 turns off the simulation, and a value of 1 will turn on the simulation. So you want to set one of these 4 to a value of 1.0 and have the others set to 0.0 to turn them off, and that will enable one colorblind simulation mode. And then, like I said, you can set the strength to anywhere from 0 to 1 to enable the amount of effect, colorblind effect that's taking place. So for my example, I'm using the first person example. I've got my first person character. To use the post-process material, you'll need to select your camera component and then go down to where the rendering features section is and add an element in that array, and then just drop in the colorblind simulation post-process material. I'll have a zip file that contains the material and the parameters, and I've also got a material function to make it easier to do matrix multiplication to transform colors between various spaces. So let's take a look at the material itself. Here's what the material looks like. I mentioned this is a post-process material, so if we look at the input, it's basically grabbing the scene texture as input, and then it takes the colors and passes them through various stages depending on which colorblind simulation mode is enabled, and then finally it will output the modified color to the screen using the emissive color of the output of the material. And I won't go through all the details of the way the material functions, but that'll be documented on the GitHub page that I've created for this project. I mentioned along with the material, I've also got a material function that allows you to do matrix multiplication so that we can transform things between various color spaces. So let's take a look at what that looks like in the world. For the first-person template that I have here, I've modified it and added a color wheel in the world so that we can see the effect of turning on various colorblind simulations. So let's take a look at that in game. Got the standard shooter mechanics. So for the 4 modes, I've created blueprint for my case that allows me to easily switch between the modes. So let's go ahead and turn on Protanopia, and that's the first of the 4 modes. You'll notice with Protanopia there's no reds or greens. Everything is blues or yellows, or shades of blue or shade of yellow. If we go back to normal mode, you can notice that, like where the red is at the top here and the green on the side, with Protanopia there's no red, there's no green. People with Protanopia or protanomaly, which is a degree of Protanopia, have difficulty seeing reds and greens. They basically just see things as blues and yellows. One of the other modes is Deuteranopia, which is similar to Protanopia. This is what Deuteranopia looks like. You still have loss of red and green colors, and you can only see blues and yellows. And so that's normal again, and then we have Deuteranopia. So that's something to keep in mind, that the majority of people who are colorblind have either Protanopia or Deuteranopia, and those people have difficulty seeing reds and greens. To them, they look like yellow or orange. So it's important that if you have something in your game where you're trying to distinguish between 2 different colors, like a red team and a green team, that's probably the worst color choices you can pick for someone who's colorblind, because they can't tell the difference. They can't tell who's on their team because they both may look yellowish or orangish. The third colorblind mode is called Tritanopia, and that looks like this. You can see reds and blues, but you don't see yellows or greens. So comparing to normal vision, areas that were green and yellow here become light shades of blue to someone who has Tritanopia. And then the final mode is monochromacy, which is where everything just appears as shades of gray. So you've got darker shades of gray, lighter shades of gray, but there's obviously no color at all. So that's what that looks like for my color wheel. Now let's take a look at an actual game and see what things look like when we're playing a game. Okay, I downloaded one of the example games that Epic makes available to Unreal Engine developers. This game is called Unreal Match 3, and it's a tile matching game where you try to match up 3 tiles of the same color, and then those tiles will disappear and be replaced by other tiles. And let's take a look at it. I've got the ColorBlindSimulation post-process material added to the camera here, and so I can enable the simulation and see what that looks like while the game is in progress. So we basically have tiles of 4 different colors: red or blue or green or yellow, and when we match 3 up of the same color, then they'll disappear, 3 or more. So let's take a look at what things look like with Protanopia enabled. Here's our Protanopia simulation, and you can see that there's basically just blue tiles and yellow tiles. We've got some that are darker, lighter, but it's hard to tell the difference. Like if I go back to normal vision, the yellow and green tile here, when viewed using the Protanopia simulation, it's much harder to distinguish between those 2. So it's more difficult for someone with color blindness to be able to play the game properly. If we look at Deuteranopia, it's a similar situation. We have yellows and blues, but some of the shades are a little bit difficult to distinguish between. Let's turn that back on again. So like you'll notice that some of the darker colors here, the reds and the greens with Deuteranopia become a little bit harder to distinguish. The third simulation mode is Tritanopia, and here we have blues and reds, and you'll notice that they're a little bit more difficult to discern the difference. If I go back to normal, the tiles that are green and blue, it's easy to get confused between those two because they look very similar. And so you need to keep that in mind when you're developing your games, that you don't want to pick colors that are going to make the game more difficult for someone who's colorblind. Let's let the timer run out here. We'll let it refresh. Okay, so let's take a look at what things look like for someone who has monochromacy, where they can't distinguish any colors at all. So, oh boy, this is a little bit more difficult. Everything's shades of gray. We've got things that are lighter colored and things that are kind of darker colored, but it's hard to tell the difference between some of the darker colors. Things that are blue and red with monochromacy tend to look like they're the same color. And so that again is more confusing, and this makes it very difficult for people who are colorblind to play the game. So that gives you a good example of how you could use the tool to play your game and identify problems where color selection might be more difficult for someone who has color blindness, and hopefully you can use that to either implement a colorblind specific color set for your game, or alter the colors in your game so that it's a little bit easier for someone who is colorblind to be able to play your game.